Fundamental counting principle. In this video, you will learn how to use the multiplication principle. That is one of the counting techniques. Before you work through this video, you will need to know the factorial notation. If necessary, you should refer to the following video, which covers this topic. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. In many real-life problems, you want to count the number of possibilities. Consider the situation where you own a small deli. You offer 3 types of meat: ham, turkey, roast beef, and 2 types of bread, white wheat. How many choices do your customers have for a meat sandwich? One way to answer this question is to use a tree diagram to count how many choices customers have. The first choice is the choice of meat, and the second is the choice of bread. The tree diagram shows the possible outcomes. From this diagram, we can see that there are a total of 6 options or 6 possible outcomes. For situations in which the number of choices leads to a small number of total possibilities, you can use a tree diagram. But drawing a tree diagram would not be practical if you have 7 types of meat and 6 types of bread. We, therefore, need a better method for calculating the number of possibilities. A procedure known as the fundamental counting principle or the product principle is very useful in this endeavor. The fundamental counting principle states that if there are X ways in which the event A can be done, and Y ways in which the event B else can be done, then there are X times Y ways in which the 2 things can be done, one after the other. The fundamental counting principle works only to independent events, that is, events in which the outcome of one event does not change the possible outcomes of the other event. Note that the choice of the type of meat does not affect the choice of the type of bread. So these events are independent. Another way to count the number of possible sandwiches is to use the fundamental counting principle. Because you have 3 choices for meat and 2 choices for bread, the total number of choices is 3 times 2 equals 6. We now will see how the fundamental counting principle works. If ice cream sundaes come in 5 flavors with 3 possible toppings, how many different sundaes can be made with 1 flavor of ice cream and 1 topping? In an attempt to find the count of how many sundaes are possible, a tree diagram could be drawn. Unfortunately, this process can be very time-consuming when dealing with a large number of options. Therefore, we will use the fundamental counting principle. Here, the choice of a flavor does not affect the choice of a topping. So, these events are independent. Applying the counting principle, we have 5 choices of flavors and 3 for toppings. So, the total of different sundaes is the product 5 times 3. We have 15 possible sundaes. A school plays a series of 4 soccer matches. For each match, there are 3 possibilities: a win, a draw, or a loss. How many possible results are there for the series? There are 4 matches, therefore the number of events is 4. There are 3 outcomes for each match: win, draw, or lose. There are 3 possible outcomes for each of the 4 events. Therefore, the total number of possible outcomes for the series of matches is 81. A debit card requires a 5-digit personal identification number PIN consisting of digits from 0 to 9. The digits may be repeated, but the first digit cannot be 0. How many possible PINs are there? A debit card requires a 5-digit PIN. Therefore, the number of events is 5. We have 5 independent events. There are 9 ways to choose the first digit, since 0 cannot be the first digit. Then there are 10 choices for each next digit. The standard configuration for New York license plate is 3 digits followed by 3 letters. How many different license plates are possible if digits and letters can be repeated? A car license plate is to contain 3 digits followed by 3 letters. So there are 6 events. There are 10 choices for each digit and 26 choices for each letter. We can use the fundamental counting principle to find the number of different license plates. How many different license plates are possible if digits and letters cannot be repeated? If we cannot repeat digits, there are still 10 choices for the first digit. But then only 9 remaining choices for the second digit and only 8 remaining choices for the third digit. Similarly, there are 26 choices for the first letter, 25 choices for the second letter, and 24 choices for the third letter. We can use the fundamental counting principle to find the number of different plates. You are buying a new skateboard. There are 2 styles, wood or polymer. There are 4 colors, red, black, blue, orange. There are 3 designs, line art, tattoo, splash. But the salesman says you cannot choose orange polymer skateboards because they are all sold out. How many choices do you have? Some situations involve dependent events. Your choices are no longer independent of each other. The color options now depend upon which style board is chosen, wood or polymer. With dependent events, the outcome of one event does affect the outcome of another event. The fundamental principle of counting applies to both dependent and independent events. But we must be careful when applying it. You have all of the wood skateboard options, which will be 12 options. Under the polymer skateboards, you have 9 options. The total is 21 choices.